All right, kids, this is how to do mole homework number 1 and mole homework number 2. First question was, how many atoms are in 2 moles of aluminum? So we're going to start out with 2 moles of aluminum over 1. We do that to make sure that you realize that the moles of aluminum are in the numerator. They are, but by doing this, you see they are. Now, to go from moles to atoms, the toll on the bridge, or the conversion factor, is that 1 mole equals Avogadro's number of atoms. That means 6.02 times 10 to the 23rd atoms of aluminum is the same as 1 mole of aluminum. They're equal. Since we start with 2 moles of aluminum in the numerator, we put 1 mole of aluminum in the denominator, and the moles cancel. And then mathematically, we end up with this bigger math problem, 2 times 6.02 times 10 to the 23rd. Now we're going to do the math in the front first, the 2 times 6.02, and then whatever that is, times 10 to the 23rd. And the answer is going to pop out to be 12.04 times 10 to the 23rd. Now the rule in our class is the coefficient can never be greater than 10. So I'm going to adjust 12.04 down to 1.204. I made it 10 times smaller, therefore I have to have 10 times greater than the exponent. The answer is 1.204 times 10 to the 24th. We're going to disregard significant figures. 2 moles, I guess in my mind, was unlimited significant figures. The second question is actually really easy. How many molecules are in 1 mole of carbon dioxide? There's no math here. This is a definition. There's Avogadro's number of molecules of CO2. 1 mole of CO2 is equal to 6.02 times 10 to the 23rd molecules of CO2. Now in these problems, we have these fancy formulas. We just have to count the oxygen atoms. Now this is practice for when we have to do molar mass and percent comp by mass. This first formula is aspirin, and the letters in the front don't matter. We just have 4 oxygen atoms. In the middle one, we have that NO3 in parentheses. This is a fancy formula, but it's NO3 triple. So it's NO3, 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 which means there's 9 oxygens. In the middle, we have that BrO3 in parentheses, and it's doubled. So that's going to be 6 plus 1. So that's going to be a total of 7. And where it says 10 oxygens is wrong. That's Charlie Albuso being dumb. It's going to be 6 plus 1, or 7 oxygen atoms. Oh well, oops. Next one. We have 1.50 times 10 to the 23rd molecules of ammonia. How many moles is that? We're going to go from particle island to mole island. We're going to convert from number of molecules to number of moles. The toll, or the conversion factor, is 1 mole of anything. In this case, it's ammonia. 1 mole of ammonia equals Avogadro's number of molecules. Since we start with molecules in the numerator, we're going to put the molecules in the denominator. And this is a big problem. It doesn't actually fit on one line unless you write really small. So I moved it now to the second. And let's see what we get. See how the molecules in the numerator and the denominator cancel up above? And we're going to break it apart into an easier to deal with problem. We're going to have 1.50 in the numerator divided by 6.02 in the denominator. And we're going to multiply that by the exponent in the numerator divided by the exponent in the denominator. And the only unit left, of course, is moles, which is what we want. In this next slide, we see that 10 to the 23rd divided by 10 to the 23rd cancels. That equals 1. So really, this just pops out to be 0.249 moles of ammonia. In this next one, we actually have 1 billion molecules of oxygen, 1 times 10 to the 9th. Now, that's a lot of molecules. If you had $1 billion, you'd be as rich as Jay-Z, I suppose, or Oprah. That's a lot, but not when it's talking about molecules. We're going to go from molecules to moles. We're going to use the same conversion factor, 1 mole of anything, in this case oxygen, divided by Avogadro's number. Molecules in the numerator means that the molecules have to be in the denominator for the conversion factor. And in this next slide, I didn't cancel the molecules out, but they did. We have 1.0 in the numerator divided by 6.02. And then we have 10 to the 9th divided by 10 to the 23rd. This is going to turn itself into a very small number of moles. Now that unit there is also wrong. That unit there right here, it should say moles. And I did it again. So here we go. 1.66 times 10 to the negative 14th. And that's got to change because the coefficient has to be greater than 1. So if I make the coefficient bigger, I have to make the exponent even smaller. And when they're negative exponents, the bigger the negative, the smaller the exponent. And this answer should be 1.66 times 10 to the negative 15th moles of molecules. That says molecules. It should not. It should say moles. In this next one, we have what looks almost like a mole of bromine, but it's, look, 10 to the 22nd. So this is almost like a little trick. And in some ways, you don't even have to do math because 1 mole of bromine is, of course, Avogadro's number. 6.02 times 10 to the 22nd divided by 6.02 times 10 to the 23rd. You can actually do that in your head. The front part's going to cancel. 10 to the 22nd divided by 10 to the 23rd is 10 to the negative 1, which is a tenth. So a tenth, or in this case, I gave it 3 significant figures. You have a tenth of a mole, or in this case, 100 thousandths of a mole, which is a tenth. In this next one, we have a giant number of atoms, and we have to go to moles. We're going to go from particles to moles again. 4.81 times 10 to the 24th. That's a big number, bigger than a mole, divided by the conversion factor, 1 mole over Avogadro's number. Now we're going to break it up again. We're going to have the 4.81 divided by 6.02 and the 10 to the 24th divided by the 10 to the 23rd. And the units are correct here, moles of lithium. So we have 7.799 times 10 to the first. 10 to the first is equal to 10. So we'll just fancy this up and make it 7.99 moles of lithium. Now that was homework number 1. Here comes homework number 2. You had to do the molar mass of 4 compounds. And of course, the tricky part was to write the formula. In this first one, we have ammonium phosphate. Ammonium is a polyatomic cation. Phosphate is a polyatomic anion. It's positive 1 and negative 3 charge. When we crisscross, you should do this in your head. You should say, I need 3 ammoniums and 1 phosphate. That means the ammoniums have to go in parentheses. So the formula is going to be ammonium in parentheses times 3 with a single phosphate. In this compound, there's nitrogen, hydrogen, phosphorus, and oxygen. And now let's just count. There's going to be 3 nitrogens because the ammonium is tripled. There's going to be 12 hydrogens because the H4 in ammonium is tripled. There's 1 phosphorus and 4 oxygens. The molar masses I got from the periodic table. The molar mass of nitrogen is 14 grams per mole. The molar mass of hydrogen is 1 gram per mole. The molar mass of phosphorus is 31 grams per mole. And oxygens are 16 grams per mole because they're not Hunkelgriff twins here. They're individual oxygens. When you sum that up, the unit changes to grams per mole. The molar mass is always in grams per mole, 149 grams per mole. Next one up is lithium dichromate. Lithium makes a positive 1 ion. It's in group 1. And dichromate's on table E. It's a negative 2 ion. Cr2O7, negative 2. Now crisscross, we're going to need 2 lithiums and 1 dichromate. In green, that's the formula, Li2, Cr2O7. And we list all the choices here. We have the lithiums, we have chromiums, and we have oxygens. There's 2 lithiums. Each lithium is 7 grams per mole. We have 2 chromiums. Each chromium is 52 grams per mole. And we have 7 oxygens. Each is 16 grams per mole. We multiply across, then we sum it up. The unit for molar mass is 230 grams per mole. Now for the next 2, I took a shortcut because I'm not getting graded and I don't want you to do what I do, but you should be able to see clearly what happened. In gold, Roman numeral 1, thiosulfate, the gold ion is positive 1, thiosulfate is a negative 2. So we're going to need 2 golds and 1 thiosulfate, Au2, S2O3. Each gold is 197 grams per mole. 2 times 197 is 394. Each sulfur is 32 grams per mole. I have 2 of them, that's 64. And each oxygen is a 16. 16 times 3 is 48, so it's 506 grams per mole. Don't do it this way. This is a shortcut because it's Sunday morning and I'm trying to get this done for you. In the last one, barium hydrogen sulfate. Barium is a positive 2 ion and HSO4 is a negative 1 ion. So we're going to need 2 hydrogen sulfates. The formula is Ba H2SO4 in parentheses times 2. Each barium is 137 grams per mole. There's 2 hydrogens. Each one is 1 gram, so it's 1 times 1. Take that back. It's 2 times 1 is 2 grams. There's 2 sulfurs. Each is 32 grams per mole, so there's a 64. And we have 8 oxygens, and 8 times 16 is 128. Don't do it this way. Do it the correct way. But the answer is 331 grams per mole. And that's it. Homeworks 1 and 2. Thank you, and hand it in soon.